Hi, so we are doing lesson 6.1 today. Now that we know what a function is, we know how to find the domain and range of functions, and we know how to evaluate functions in function notation. Now we're going to be looking at key features of graphs of functions. So our learning target today, and we are on page 81. Our learning target for today is we're going to be able to relate the domain and range of a function to its graph. And then we're going to be able to identify and interpret key features of graphs. So going through the lesson, it says roller coasters can be scary but fun to ride. Below is the graph of the heights reached by the cars of the Thunderball roller coaster over its first 1,250 feet of track. The graph displays a function because each input value has one and only one output value. We can actually, if we're graphing functions, there is actually a quick test that we can do to see if the function is a function or not, and it's called a vertical line test. So the vertical line test is a visual check to see if a graph represents a function. For a function, every vertical line drawn in the coordinate plane will intersect the graph at most 1 point. This is equivalent to having each domain element associated with one and only one range element. So we can use that vertical line test to prove that this is a function. So it's saying I can draw a vertical line anywhere on this graph and it's only going to intersect the function at 1 point. So we can do that right now. So I'm going to show you how you can use the vertical line test to prove this is a function. So anywhere I draw a vertical line, if it's a function, it's only going to intersect the graph at 1 point. So vertical line, vertical line, vertical line, vertical line, vertical line. Anywhere I draw a vertical line, it's only going to cross at 1 point. So this is a function. Erase that because we're going to be using this. So it says study this graph to determine the domain and range. The domain gives all values of the independent variable. So the domain is my inputs. So an independent variable is the variable for which the input values are substituted in for a function. It's kind of what controls the situation, my independent variable. So in this case, it's the distance along the track in feet. The domain values are graphed along the horizontal or x-axis. The domain function can be written in set notation as the set of all real numbers of x between 0 and 1,250. So it's my domain is my x, and my x's range from 0 to 1,250. The range gives the value of the dependent variable. So the dependent variable is the variable whose value is determined by the input value or by the value of the input or value of the independent variable. These are my outputs. This is based on what input, this is my output. So these are my y's. And so my y's, which are my height, range all the way from 10 feet to 110 feet. So it says, in this case, the height of the roller coaster above the ground in feet, because the height of the roller coaster depends on how far in the track the car is. The range values are graphed on the vertical or y-axis. In the range, we can see as y's that are greater than or equal to 10 or less than or equal to 110. Another key thing that we're going to talk about is the difference between continuous and discrete data. This graph above shows data that are continuous, meaning that the points in the graph are connected, indicating that domain and range are sets of real numbers with no breaks in between. A graph of discrete data consists of individual points that are not connected by a line or a curve. So continuous, the points in the graph are connected between them. Okay, and then discrete data consists of individual points that are not connected by a line or a curve. So the continuous is kind of like our Khan Academy's assignments that we had, like that went like this. And my discrete were those Khan Academy assignments that had all of those individual points. And then there's other things that we can look for in our graph. We can look at the domain and range and identify which one's my independent and dependent variable. We can identify whether this graph shows continuous or discrete data, but then there's also key features we want to be able to identify. So many other useful pieces of information about a function can be determined by looking at its graph, and these are what I want you to write down in your math notebooks. So the y-intercept of a function is the point at which the graph of the function intersects the y-axis. The y-intercept is the point at which x is equal to 0. Okay. We also have some minimums and maximums. There's actually 4 that we're going to be looking at. A relative maximum of a function f of x is the greatest value of f of x for values in the limited open domain intervals. That just means based on all the other outputs next to it, this point has the greatest output. And then we also have relative minimums, which is the least value of f of x for values in a limited open domain interval. And that's just saying based on all the points to the left and to the right of them, it is the smallest output. But then there's also something we need to be paying attention to. So it says because they must occur within open intervals of the domain, relative maximums and relative minimums cannot correspond to the endpoints of the graph. And that's because we those endpoints, we don't know how the data is working to the right of it or to the left of it. Our relatives need to have other outputs to the left and to the right of that point. But then we also have not only relative maximum and relative minimums, and everything I'm underlining, please write down in your math notebook. We could also have absolute maximum. So the absolute maximum of a function, f of x, is the greatest value of f of x for all values in the domain. So it's the greatest output that we have in our graph, which is also the same for my absolute minimum. The absolute minimum of a function is the least value of f of x for all values in the domain. So it's the lowest output that we have. And there may be a case where we don't have a relative maximum or a relative minimum, or even an absolute maximum or an absolute minimum. Something that's different from our relative, so it says, unlike relative maximums and relative minimums, absolute maximums and absolute minimums may correspond to the endpoints of the graph. It's just something to keep in mind. So then we're gonna identify some of this in our roller coaster. So it says use the Thunderball roller coaster graph on the previous page for items 1 through 5. So 1 says, what is the y-intercept of the function shown in the graph and what does it represent? So I'm going to scroll back up to my graph. So what is the y-intercept? So that's where does it cross this y-axis? Vertical axis. Well, it crosses the y-axis right here at 10. And the y's tell me the height above the ground in feet. So that means my y-intercept is 10, and it is that the graph or the roller coaster starts at 10 feet in height. Then it says identify a relative maximum of the function represented by the graph. So scrolling back up. So I'm looking for I'm looking for points in which the outputs next to it are smaller than it. And I actually have 2 of those. I have one right here and one right here. And these are relative maximums because if I look at all the other points right next to it, these have the greatest output compared to the ones that are next to it. So I have 2 relative maximums. I have 110 and then I have 90. So based on the points around it, those 2 have the higher points. Then it says identify the absolute maximum of the function and then interpret its meaning. So I'm looking for the greatest output, and that actually occurs here. So one of your relative maximums can be your absolute maximum. So your absolute maximum is 10, or sorry, not 10, 110. And so that's the greatest height of the roller coaster. So 110. That's the greatest height of the roller coaster I'm just going to write of the coaster. Oops. Then it says identify a relative minimum. So remember my minimums, my relative minimums can't be my endpoints because I don't know what's going on over here and I don't know what's going on over here. So this is my one relative minimum because based on all the points around it, it has the smallest output. So, oops, and I forgot to identify what that was. So that would be around 30, so height of 30. Then it says identify the absolute minimum of the function represented by the graph and interpret its meaning in the context. So looking for the smallest height of the roller coaster, well, that occurs both at the beginning and the end of the track. So that would be 10 feet. So that would be the lowest height of coaster. Perfect. All right, let's go to another situation. So it says, suppose you got on a roller coaster called Cougar Mountain that immediately started climbing the track in a linear fashion as shown in the graph. Identify the domain and range of the function. So the domain are my inputs, which was my distance along the track. Well, it ranges from 0 feet along the track all the way to 200 feet along the track. So my domain is less than or x is greater than or equal to 0, but less than or equal to 200 because that is my inputs. The distance on the track are my inputs. My range are my outputs, which is the height above the ground the roller coaster is. And it starts off 0 feet above the ground and goes to 175. So it would be 0 is greater than or equal, or is less than or equal to y, which is less than or equal to 175. So we have the domain and range, which are those real values in between those inequalities. Then 7 says identify the y-intercept of the function. Well, where does it cross this y-axis? Well, it crosses right down at 0, 0. So my y-intercept is 0. Or you can think about it, it's the point 0, 0. So when x is 0, y is 0. 8 says identify the absolute maximum and absolute minimum of the function. Well, remember we could have our endpoints. So my absolute minimum is the lowest height above the ground, and that's at 0. So min, I'm going to say absolute min would equal 0. Then absolute max would be the greatest height, greatest output, which would be the 175. So then 9 says, does the function have any relative maximums or minimums? So I'm looking at this and I'm not seeing any point that when I look to the points next to it, it's either the largest or the smallest. So there are no. So there is no open domain interval that has maximums or minimum values. So there's no one point that if I look to the right into the outputs to the right and to the left, they have smaller outputs or bigger outputs. So 10 says, how are the extrema different on this linear graph versus the non-linear graph for the Thunderball roller coasters? So, and then just to let you know, extrema refers to all maximum and all minimum values. Well, just based on this, on the linear graph, the extrema occur at the endpoints of the interval, so the beginning and the end. And then on the non-linear graph, so non-linear, so linear means straight line, non-linear is my curves. So on the nonlinear graph, there were some maximum and minimums on the interior as well as the endpoints. Going down, last situation. So it says Tom hiked a circular trail known as the Juniper Loop. The graph shows his distance from the starting point after 10 minutes. So my starting point is my dependent variable, starting point, and it goes back to 0, my dependent variable is the distance from the starting point, and that's why it goes back to 0, because it's circular, so once he gets to the end of the trail, he's back at his beginning. So it says identify the domain and range of the function. So the domain are my inputs, and that's the time he spends hiking. So he has 0, he spends 0 minutes hiking all the way up to, what is that? 100 and, so that would be 15, so that'd be 165. So the domain would be 0 minutes, just less than or equal to x, which is less than or equal to 165 minutes. And then the range would be his distance from the starting point. Well, he starts at the starting point, and then he gets as far as 7 miles or kilometers away from the starting point. So my range would be 0 is less than or equal to the distance, which is less than or equal to 7. And then 16 says identify the absolute minimum of the function. Well, the minimum happens here and here. So it's 0. And what it represents is Tom's least distance from the start. Because he is at the start both at the beginning and the end of the loop. So it says in this function, the absolute minimum corresponds to 2 points on the graph. What are those 2 points, and what do they represent in the context? Well, I've kind of been saying this all along. It occurs at the start, so 0, 0, so time spent hiking. He's at 0 distance from starting point. And then it happens at 165, 0, because after 165 minutes, he's made it back. So that is Tom's least distance from the starting point, occurred both at the beginning and the end of his hike. Then it says identify the absolute maximum of the function. So my absolute maximum, remember, occurs here. So that would be 7 kilometers. And that is his greatest distance away from the start. So it says, what points on the graph correspond to the absolute maximum? So it occurs all the points, oops, I'm going to erase that. My absolute maximum occurs all the points from, what would that be, 75 minutes to 105 minutes. So all the points from, well, I guess it's a little bit off, so maybe about 80 to 100. So all the points between the time of 80 minutes to 100 minutes. 100 minutes. And what does it mean in the context of Tom's hike? Well, if we think about it, if he stays a stagnant 7 miles away from his starting point and it's circular, that probably means that he stopped between 80 and 100 for that 80 to 100 minutes because his distance away from the starting point remains constant. Then it says identify any relative minimums for the function shown in the graph. So relative minimums, I'd have a relative minimum here. So 5, whoa. And then any relative maximums for the graph, that would be the 5 or 7. Because 5 can be a minimum because right in here we have, it's the lowest right next to it. And then 5 can also be a maximum because over here we have 5 being the greatest value. Your homework for tonight is the 6.1 practice. Let me know if you have any questions. You can come to my office hours as well.